sides, 30, 60, 90. Okay? Now, according to the diagram, we know across from the 90. So I know that this value down here, this 2x part, has to equal 7. Okay? Now, you can do this one of two different ways. If you just take 7 divided by 2, you probably got x equal to 3.5. Okay? Which means everywhere else you see an x, all you have to put is 3.5. So even though that you get 3.5 here, now here if you put 3.5 root 3, if you typed it in the calculator, you got some other crummy decimal. Just leave it. Leave it with the radical. Okay? That's a correct answer. Now, you don't have to multiply that through because it will give you a crummy decimal. The other way you could have done this, and it would have worked cleaner, is that in this, instead of doing straight division button, if I did x equals 7 over 2, if I left it as a fraction, if you leave that as a fraction and you go to the calculator, or not, oh, there it was. Hold on a second here. If it gets, when I move it with the screen, it gets moved off, way off to the side. Let me try this again here. There we go. Now it should show up. What happens when you duplicate your screens? You know, the resolution changes, so it gets shoved off in the corner. You can't see it. Anyway, if I use my calculator now with the 7 over 2, if I do the fraction bar of 7 over 2 times the root 3, now to leave it in radical form, 7 root 3 over 2. Either one of those answers is perfectly fine. If you ever get a value of x that gives you a decimal like that, you have to multiply by the root 3, just leave it as that, 3.5 root 3, and I would have been fine. Is that what you were wondering, how you got a weird decimal? Yeah, you did it right. Yeah, you were fine. What's it? It would be 7 root 3 over 2.
Oh, wait. Okay.
3.5 root 3. Yeah, you can do that. That's fine. Give it help. Sam. I will. I'm going to get 16. I'll hit back to those. I'll get you. No worries. All right. I swear I did 16 in class.
No, you did 12.
I did 12, okay. 12 and 16 are very similar to one another. When you get to, oh, that's right, in 6 hours, sorry. So in 16, this is kind of like your worst case scenario as far as the calculation is concerned. First things first, which of the triangles is it? Okay. So we write out our ratios of our sides. 45, 90. X times the square root of 2. And in this case, again, we know across from the 90. So I have to set the value of something times the square root of 2 equal to this crummy looking fraction of 3 root 10 over 5. Okay? Now, at this point, this is, bless you, this is just a really crummy looking value. Now, do you guys agree that I have to divide both sides by the square root of 2? Remember, it's x times the square root of 2.
Oh.
All right. Are you guys okay? It's got to be divided by. Now, before I do that, if I have 3x equals 12, we would normally write it as divide by 3 like this, correct? Did you know that, let me do this real quick. That means the same thing. Dividing by 2 is the same thing as multiplying by 1/2. Dividing by 3 is the same thing as multiplying by 1/3. If I ask you, what's half of 10, what would you tell me? What's 10 divided by 2? Same thing, yeah? It's basically what we're doing is instead of dividing, you can say you can multiply by its reciprocal. Right? So what I would do in this one here, and this is like the really, really weird case. If I move this over just a bit, instead of just putting divide by the root 2, I'm going to write times 1 over the root 2. And then I duplicate it on the other side. Okay? By doing it that way, you're still going to get the same value. I'm dividing by the square root of 2, but instead of saying divide by the root of 2, I'm multiplying by 1 over it. I'm just using a reciprocal. Okay? Now in the calculator, then all I have to do is type this in exactly the way it looks. All right? So let's see, 3 root 10. So we've got fraction bar 3 root 10 over 5 times 1 over root 2. Okay? So it looks exactly the way that I just did, and I hit enter, and I get 3 root 5 over 5. And that's that value of x. Instead of using what's called a complex fraction in this case, that's what we're doing. Right? Because you have a fraction divided by a fraction. Remember, whenever you divide by a fraction, you're just multiplying by the reciprocal. And that's the easiest way to write this one. Okay? And that gives you both sides across from the 45. All right? That one's a little weird, but as you look at it, it's not terrible, though. I hope. Did you get over it? Okay. Sam, you were saying number 8, sir?
Yeah.
Sure. Let's take a look. Eight's very similar to the one we just did with number 10, where you wind up with the half 9 when you have to divide out by the root 2, you wind up with a weird root there. So here, same idea, we start with writing out our pattern, 45, 45, 90. And then again, in this case, I know across from the 90. So I have to set the x times the square root of 2 equal to 9. And then to get x by itself, we divide out. So if I put in 9 divided by the square root of 2 in the calculator with the fraction bar, it's going to give you 9 root 2 over 2. Yes, sir. That's going to be the value of x, which goes to both of them. This is 45, 45, 90. Okay? All right, remember, use the calculator, use the fraction bar, and it'll give you the right solution. 9 over the square root of 2, and hit enter. Basically what it's doing here is rationalizing the denominator. Okay. If you guys remember last year when you worked with the square root stuff, probably not a ton, you probably did a little bit of that, where you had to get rid of the square root in the denominator. It's not appropriate to be there. We do that again in Algebra 2 a lot. We do that here, but in geometry, more often than not, the numbers are clean-ish, and the calculator does it for you. As you get to Algebra 2, there'll be a lot more stuff you'll be working on your own for those things. Right. Does that help on that one, Sam? And then, let's see, you said 9, if I'm not mistaken. Yeah, 9, again, you've got the 30, 60, 90. Just trust the fact that you know how to solve a one-step equation. You know that across from the 60 in this case. So as we go through, we have a 30, 60, 90. Right on our sides. Looks at something times the square root of 3, and looks at double something. In this one, we know across from the 60 is 4 root 15.
So that'd be 4 root 15 divided by
Root 3. Yes, sir. That's your answer. So then you divide this out by the square root of 3 to get the x value by itself. So put this in the calculator. 4 root 15 over, oops, sorry, I hit 14 by mistake. Oh, that would have been a good example of, remember I tell you guys to write out what you're doing in the calculator before you do it? I accidentally hit 14, but I was doing what I wrote down. And I get a value of x that's 4 root 5. Okay. So my common multiplier for everything, this value of x, is 4 root 5. So everywhere else I see an x, I put a 4 root 5. So down here, we have 2 times the 4 root 5, otherwise known as 8 root 5.
Oh, so you have to multiply it? That's not good.
What do you mean?
So if that would have been, so if that would have been across from the 90, then you would have divided it, right?
Correct.
But if it's not, then you would have multiplied it?
Yes. Remember, once you find that value of x, depending upon where you're at, if you got it from the 30, you just substitute in the other two. Sometimes if you're at the 90 first, you have to divide and then substitute. So you have to divide and substitute usually for most of these, or 2/3 of them. One of them you have it right from 30. And that's the idea. That's how the pattern of this stuff goes. Okay? But it all stems from, you gotta write this out. Okay? That's the big thing. Okay? What else was weird?
Number 7, 5, 3, 4, 6, 1.
7? Oh yeah, with the weird root? Okay. Remember, it doesn't matter what's there. Okay? It doesn't matter what's there.
The only version is number 16.
Did it make sense now though?
Yeah. It's not that good.
You just gotta trust yourself. Okay? You just gotta trust yourself. So even though you have 7 here, you have 45, 90. Okay? In this case here, you go across from which one? 45. So across from my 45 is 3 root 3, which means everywhere I see a value of x, I'm going to put 3 root 3. Now, here, I'm not dividing anything because it's 3 root 3 times the square root of 2, so I'm substituting it in. So I type that in the calculator. Be careful when you have the fraction bar to make sure you get out from underneath it. 3 root 3 times root 2. You get 3 root 6. That's it. Sam.
Wait,
You're the worst. What's that?
I got 3 root 6 over 2, but I divided it.
That's why you got it wrong. Remember, you know the value of x. Oh. You know what x is. You're just substituting in everywhere you see it. You're not setting it equal here. That's why you got that one wrong. Okay? You got to make sure you see what you're looking at there. I'm sorry, what's that?
Are you told you're like going to be multiplying or dividing with no one column that has like the 2x
Because here, I know x. If I know what x is, I'm just substituting it in for x. I don't know across from the 90. Since I don't know across from the 90, I'm going to have to multiply to figure it out. Okay? Whereas if I know across from the 90, I think I know across from the 90, I had to divide to get the other things. Okay? That's how that works. So if you don't know, you're going to have to multiply. If you do know, you got to divide. And that works also for the 60 as well.
That makes much more sense.
Okay? So if you know the 60, you got to divide. And then it means you have to multiply and multiply. If you don't know the 60, you knew either one of these two, so you'd have to multiply. All right?
That makes more sense.
Or the 90. Again, each problem's different. You have to make sure you understand that. That's why we set them up as these equations. So if you had to solve for x, that meant you had to divide something. Once you know what x is, then you're substituting. When you're substituting, you're multiplying. Right? Now, as this stuff starts to get a little bit trickier, we start to get into, there wasn't on the sheet, we start to get into what are called combos. And I want to show you a couple of those today here. So what happens here is we're going to go into the same stuff, but we're going to combo some stuff together. What I mean by this combo idea is that from time to time, we're going to work through one set to another.
Can we keep these?
Yeah. For example, this isn't the easiest to draw, but you can still do the algebra. As we get into these things, we're going to be looking to find one side length off of multiple triangles.
Actually, you know what? I did make this copy, guys. I'm sorry. So here. So we don't have to draw it?
No. Yep, sorry. I hole punched it.
You hole punch? The whole one.
So as we get into these things, we're going to start looking at multi-step ones. And let me open up the right file. I think I had this one in here. How do I not have this one saved? Jeez. I just did this.
Joe,
Anyway. Did I put it on the calendar? I must have put it there. I'm sorry, guys. For some reason, I didn't save this correct file, and I want to make... No, I didn't even put it on the calendar. Dang it. Oh, well. All right, so you'll have to bear with me as I try to draw this. Now, in this first problem here, we have two 45, 45, 90 triangles. You guys okay with that? So here's what's happening. We need to work from one triangle to the other to find out what the missing side is. In this type of problem, we're looking at just solving for one side, but yet you have to use multiple parts to get there. So what we do is we look at the diagram to figure out what type of triangle do you have value for. What I mean by that is, do we know one of the side lengths?
Yes, sir.
What do we know? 10. Is 10 in a 45, 45, 90 or a 30, 69? Good. So we started with that. 45, 45, 90. Looks at x, x root 2. Across from which angle do we know in that first triangle? The 10 is across from it's across from a 45. Good. So that means across from the other 45, it's going to equal how much? And across from the 90, it's going to equal what? Very good. It's going to be 10 square root 2. Now, when we go to label that into the diagram, this is where we have to go use this. This was a 10 here. Now this is a 10 root 2. Have I now jumped into the other triangle? Yeah. So I've gone to the second triangle now, which means I have to reset. And I'm writing it as a 45, 45, 90 because I know it is. And I reset my unknowns. Remember, this value of x that they're solving for here is just that. Remember, that is just the missing sideline. Think of it as just a question mark. It's not the value of x that we're solving for. It's just that's the missing side we're looking for. Okay. So across from what angle now do we know in that second triangle? A 45. So now I know across from my 45 is the 10 root 2. So in my next triangle, the value of x is now 10 root 2. So in this setup, everywhere I see an x, I'm going to put 10 root 2. Now, did I have to do any math to get this x value of 10 root 2? So it means the math that I do here is going to be multiplying or dividing? Multiply. I'm going to multiply. Since I didn't math anything, I'm just substituting in. So it's 10 root 2 times root 2. And you get 20. Very good. Okay. So what's happening is you're bouncing from one piece to the next. You're still utilizing the exact same things we were working on. We're still setting it up the same way. You're just adding an extra step to it. Okay? Let's take a look at the next one. Again, I apologize for my drawing skills. What?
I did know it.
Yeah, give me a sec. Let's put a question mark there. Okay. So, I think I know that in there, right? Sorry, my hand. Yes, sir. Are they both 45, 45, 90s?
I got it.
Oh, sorry, I forgot to label the other one.
I got it, Mr. Orr.
Yeah, it would be for example.
I got it. Okay, so it's 45, 45,
Good. So, okay, keep doing it. Yeah. No.
How long are we gonna finish that?
Oh, come on.
Really?
Sure. So tell me what first thing I do is label out, you're right, first triangle is 45, 45, 90.
Well, they're both going to be 45.
Well, the info we start with, we're going to start with the one we know, and you're right, they're both 45, 45, 90, so we're going to use it twice. Right. Across from the 45 is 7, correct, so we have to, move this over here, I'm going to write out my side lengths, my ratios, x, x, okay, very good, so it's 7.
You multiply that, and then you multiply that with square root of 2, and then you get 14. You got that, so you get only 7 square root of 2, and like I said, multiply that by square root of 2, and you get
You got it, man, you got it, that's the Christian. So what Christian's saying here is that he's figured it out right away because he found out that moving the pattern, root 2 times root 2 is just 2. So he figured that out real quick. Now, we've jumped enough information to get to the second triangle, so once we get to that second triangle, I want you guys just to reset and rewrite. So for reset and rewrite, again, we have another 45, 45, and a 90. Now, across from this one is a 7 root 2, which means across from the other one is a 7 root 2. And then move this up here. Now it's going to be 7 root 2 times the square root of 2, which is 15. That's it up. I want to go to one that has the difference.
Alright, which one? You, right, number 6 is different. Unless you
Yeah.
you go 60 or 39.
Yeah, I was gonna do that one next. I'm gonna go down to number 5. Because then we'll do a couple of them like that, and then we'll switch between the two different types of triangles when you have to use one of both,
Yeah, you should do
both
like
sides.
11 or 9 or
Yeah, they can get kind of messy.
complex.
So let's see here. If I had number 5, we're 30, 60, 90. 30, 60, 90. Hey, that's not that bad.
What?
I'll say my drawing here.
We're on number 5, right?
Yes, sir. This is number 5. All right. So again, in this case here, ladies and gentlemen, we know we've got 30, 60, 90 triangles. We actually have 2 of them because there's 2 60s. So we use them to go through. So we write out our sides to start with. 30, 60, 90. Okay. Across from which those 3 angles are you given in the first set of triangles? The first triangle. Across from the what one? The 30, correct. So remember, the angle always opens up to the side opposite, so the value of x in this case is actually 6. So now, do you really need to substitute into both of these? No, which one do you only have to worry about substituting into? The 90, correct. Because if you look at the diagram, I need to get to this side length here, so that one's going to get me across from the 90. So if I just take the 6 here, and this will be 2 times 6, I get 12. Would you be wrong if you wrote this was, oh, this is going to be 6 root 3? No, you just didn't need that side length in the diagram. Right? It's extraneous, it's extra information, don't need it. Erroneous. Extraneous is a solution that doesn't work. Anyway, that's why I teach math, vocab. All right? Are we now in our second triangle? Yeah. So in that second triangle, sorry, English teachers. I reset. Across, are we at 30, 60, or 45? 30, 60. Again, it tells you. So we reset 30, 60, 90.
Whoa.
What was it? Which one is it now? What across which angle?
60.
Good. So now in this new set of the algebra jig that we called it, we know across from the 60 equals 12.
So we should divide it?
Correct. Yep. So now you're at something times the square root of 3 equals 12. Having to solve this one out, since you know across from the 60, you have to divide. So in our calculator, we divide out 12 by the square root of 3. And I think you get 4 root 3. Does that sound right?
Isn't that your? Because you were trying to find. Yeah, right.
So the 12 divided by the square root of 3 gives you the value of x, which is 4 root 3. That was right. So back in our diagram, I think you were saying which angle you have to get across from. Yes, you're right. We have to work across from the 30. Well, that means this is 4 root 3. Remember, you're using one to get to the other, but the mathing of it is identical to what we've been doing. The mathing of it doesn't change. Okay? Why don't you guys take a second and try number 8. Okay? Take a second and try number 8. All right?
You go down. What? Yes. 290. Oh, you didn't move.
I didn't need to. See, you look at the picture.
I don't know. That's it.
So if I did that, I would see it's 4 root 3 and 12 by 2. It's 4 root 3. Perfect. I thought you did it twice. I thought you were trying to give me a test for him. What's up?
Like, because it's my basis, so where's the equal?
What do you think? Everything.
See, I told you. You're saying it right there. When? Right.
I wouldn't trust her at all. I mean, really. I mean, she means well, but you know, she's also trying to be a pain in your teeth. Is the six. Hey guys, maybe we should start making a tally here of when to multiply that, because that's when you guys are starting to really mess this up here. So,
I get it now.
if you are in a 45, 45, 90, if you know opposite the 45, then you multiply to find across from the 90. If you know opposite the 90, you divide. Okay? So if you know across from a 45, you multiply to get what's across from the 90. If you know across from the 90, you divide to get what's across from the 45. Okay? And it's going to work the same way with the other ones. If you know opposite the 30, multiply to find the others. If you know opposite the 60, divide to find x, then multiply for opposite the 90. You know opposite the 90, divide to find x. Then multiply others. Multiply for opposite the 60. Okay. Remember, think of it this way. If you're given this, that's x. You just multiply it. If you're given this, that's x. You just multiply it. If you know across from here, that means that this value equals something. You got to divide to figure this out. Then you substitute. Okay. It's simple, like that way you don't do what you were trying to do. Oh, it's 6, so if it's got x has got to be 12. It means that the value that you're looking at is represented by 2 times something. Well, that something is 6. Okay? Remember, that's what this means. It's looking at 2 times something. That something is being represented by a number. Okay? Figure out what the something is. Same. Oh, I haven't gotten that far yet. Let me pop this in here real quick. What did I say to look at number 8? All right. So, what are the 2 types of triangles we're working with here? They're both 30, 60, 90. So, we okay with that? So, again, we start out 30, 60, 90. In that first triangle, what angle do you know opposite of? The 90. So I know that I'm looking at the 90. So the 90 looks at something that's 2 times something. Well, that 2 times something had to equal what? 6. What's x? 3. Right? So now, to get to the second triangle, across from what angle do I have to work with?
60.
If I use across from the 60, that gives me down to here.
Oh no, I thought you were talking about the other triangle.
I'm sorry. I meant from this triangle to get to that one. I got to go across from my 30, right?
Yeah,
So across from my 30 is going to equal how much? 3. Good.
And then that's when you can go across the 60.
So now we're in our second triangle. So I'm going to switch my color here. So we have a 30, 60, 90 again. Across from which angle do you know now in that second triangle?
60.
60. So that 60 is something times the square root of 3 has to equal 3. Okay? So you've divided both sides by the square root of 3.
I got square root of 3.
And you're correct.
Okay. That was wrong.
No, you're not wrong. So you're weird. So your value of x is the square root of 3. Now, across from which angle are they asking you to solve for?
30.
The 30. So that means that this has to equal square root of 3. Yep. That's what it has to do. Let's see. We did not get to the combos, which is fine. So you've got what? 7. Why don't you guys do the ones we just did? What? 1, 2.
We did 1, 2, 5, 8.
So do 3, 4, 6, and 7. All right. Do 3, 4, 6, and 7. There's 4. We'll try those for tomorrow. We'll do the count, the switch between the two triangles. We'll do that tomorrow. It's not any more tough. It's just we just ran out of time. So,
I want to know something. I want to know what number is right.
yeah, finish up. Make sure all of them are done all the way up to number 9. Because after number 9, everything goes between the two different types. We'll work on that style tomorrow.
So 5.
Yeah, whatever. I mean, make sure everything up to 8 is done. Okay, make sure everything up through 8 is done. No, just switches the two triangles. There's no reason to do that. We haven't done that yet.